For the next segment of installing the NEO 3D printed tracks fixtures, we're going to take a look at the prep work that's required for the modules to be in a position to receive these fixtures that can also act as butt joints. And this is where we might lose some of our modelers here, because forever the Fremo standard has utilized 1-inch bridge rails as a means of connecting two different modules together. And one of the unintended consequences of that has been some pretty sloppy work on framing and track work, with a little bit of a mentality that, well, the bridge rails will correct that. The two things that we're seeing in Fremo are here between the end plate and the sub roadbed. And there's a couple of issues there. One of them is that the standard requires that they be perpendicular to each other, and oftentimes they're not. So we don't have any tolerances in Fremo. This module is at 89.85 degrees, and there are no tolerances in Fremo, but if you do the math, 1 inch of variation, or 1 degree of variation, so 91 degrees or 89 degrees, and 6 inches of run is a 1/8 of an inch fall or rise. So that's a little steep, and I'm not sure that would work for 89-foot passenger cars, 89-foot flats, or the long articulated locomotives. If we stick to a tolerance of 1/2 degree, so anywhere between 89.5 to 90.5 degrees, then in a 6-inch run, it's only a 1/16 of an inch rise or fall. While there are no standards in Fremo, that might be something that unofficially could be used as a reference. So making sure that our end plate is square. If we try to install these track fixtures, and obviously this is an exaggeration, but if we try to install a fixture like this or like this relative to an adjacent module, the results won't be very good. Another thing we're seeing on the sub road bed is we're seeing a lot of modules that will bring the sub road bed up to the top of the end plate, trying to make it level. And too often what we're seeing is something like this, where instead of being nice and flush, we're seeing either a rise or a dip. And then with homemade cork or other fixtures, that's affecting the end of the track as well, with either a sharp increase or decrease in the rail. Some of the guys will take their end plate and they'll do a dado or a rabbet to provide a base for their sub road bed. What I elected to do on the Dallas Union modules was to set my sub road bed 1/2 inch on top of the end plate, and then all the sub road bed is braced with 3/4 inch by 1.5 inches in order to keep it not only supported but square to the end plate. Another thing that we're seeing are bowed end plates. Plywood is not straight. Plywood, while it is thermally stable, it is subject to humidity fluctuations. And too often we're seeing end plates that aren't straight. And what we're seeing when we get to a setup, when two modules are butted together, if the end plates are convex, the modules are clamped in the middle, and then you can look at the ends and there's a significant gap on either side. Or if they're concave, the ends will clamp together, but then there's a gap in the middle where the two modules are coming together. So what's going to be required for any transition or use of butt joints is actual square modules that are true. We need two modules. We use these 1, 2, 3 blocks as a reference. The modules need to come together. They need to be square and they need to be true. If we're trying to take a square module, this is obviously an extreme exaggeration, but against a module that is convex, we're going to have this scenario where we really don't know which way does it orientate on the module. But also, instead of also getting laterally and vertically aligned, we also have to spend a considerable amount of time trying to figure out, well, which way do we orientate this module in order to get the tracks aligned. If we're trying to bring two convex modules together, then we have a similar problem. And obviously, if we're trying to do something that's concave, then the problem's reversed, where the modules will mate on the corners, but then there's a significant gap here in the middle. And obviously a gap with any sort of a butt joint is not going to be beneficial. The method that we've always used here in Texas for truing the end plate and making sure that they are laser straight is to tee them in the back. So all of our end plates, and this is a 3/4 inch Baltic birch, as well as this, 4 inches across. And this edge either needs to be a factory edge or run through a table saw. Not jigged or skill saw. This needs to be a true edge. The corners are then clamped into position in the corners of the module, screwed in 3 locations, and that will true up your end plate. Even high-end Baltic birch, which is $110 a sheet right now, when cut, is not straight. So all the end plates on all of our modules are teed in order to keep them true, so that when this module is butted up to any other true module, it'll be like these 1, 2, 3 blocks where we have 2 true and square edges mating together. Most of the modules that I've seen that are not true are capable of being corrected. There's several module designs out there that have leg pockets in the corners. Those may need to be relocated a little more interior. This is a fairly simple fix. Once you get your dimensions calculated on the ends, get the piece cut, installed. Obviously, if your end plate is concave, and if you're attached here, you're going to have to, if your sub road bed is attached to your end plate, you'll have to loosen that connection in order to true your end plate. But this is going to be critical if we're going to transition, or if an individual modder is going to transition to using a 3D fixture with a butt joint. On top of having the module face and the module end true and square, the surface needs to be prepared. This module, this is the north end on the prototype. This was the Katy trackage. This was the Rock Island, and these split just north of here. But this previously was cork, Midwest Products cork. And I believe at one point there were actually gap masters that were here that were being used as anchors, and those have repeatedly failed as anchors. And that was another event motivating the design and necessitating something different for the ends. But if your sub road bed is wood, you can get this cleaned off well with chisel, with sandpaper. Get a nice smooth, get a square surface. If you have some deviations, if you're not entirely square, I believe Northern California Fremo has some really good articles on truing the end plate if it needs to be, or the bottom needs to be brought in or out. It's probably not something that's easily done by changing the sub road bed. Modifying your end plate to get this true would be an option. So So with the sub road bed clean, ready to accept the 3D fixture, with my sub road bed very close to 90 degrees, and I don't know that we could get exactly 90.0 without probably a little bit of luck. I'm currently at 89.9 on this one. And with the square, straight, and true module end plate, we're ready to begin the next phase of actually installing the 3D fixture onto the module.